For those in the tech world, they know that our next speaker, Jim Zemlin, is a rock star. And for those of you who may not know him yet, you should know Jim Zemlin is a rock star. During his time in his industry, he's seen the rise of groundbreaking technologies, such things as mobile computing, open source software, and of course, the cloud. As executive director of the Linux Foundation, Jim has used his considerable experience over the past several decades to accelerate innovation in technology through the use of open source and Linux. Now, it's no surprise that the White House has now come calling, announcing a partnership with the foundation to enhance cybersecurity. As part of the Cybersecurity National Action Plan, the Foundation's Core Infrastructure Initiative will work to better secure the Internet's open source software, protocols, and standards. Jim also collaborates with some of the world's largest technology companies. Have you heard of a few companies like IBM, Intel, Google, and Samsung, along with others? He's working with those companies to determine where we, as consumers of all things tech, will head next. Now, open source has very exciting implications for intelligent transportation. You simply cannot move into the new world of integrated mobility without open source code. From passenger and freight logistics to location-based services to traffic management, open source has the potential to drive what Jim's foundation calls the next revolution of human mobility. But in this age of connectivity, do we rely on open source? Is it the most secure? Is open source truly the infrastructure of things? Well, we're going to find out. So please give a big welcome to the rock star of open source, Jim Zemlin.
How many people here recognize this? How many of you? Most of you? All right. That's the Linux Penguin. So Linux is the software behind the software. It is the world's largest. It is the world's fastest. It is the most prolific software platform in the history of computing. Linux is used in the vast majority of mobile devices. 90% of the world's global trading platforms, equity trading platforms, run on Linux. So it's safe to say the world economy runs on Linux. Linux is a collective R&D value of more than $10 billion, freely available to anyone to use in any way they like. Powers 92% of the world's supercomputers. 700,000 televisions are sold every single day running Linux. 1.5 million mobile devices are activated every single day running Linux. Linux changes 7.7 times per hour. It is an incredible development feat. And so I know that I was introduced as a rock star, but I'm sure most of you have never heard of me. But maybe you've heard of this guy. Does anybody here know who this person is? We got a shout out over there. That's right. This is Linus Torvalds. He is the creator of Linux. He started Linux as a project in his dorm room in Helsinki, Finland, over almost 25 years ago. And Linus didn't just write Linux. He actually wrote something called Git as well. Git is now the tool that is used to develop software, powers things like GitHub and other things. It is the most popular tool that's used to actually create software in the world. This is the equivalent of 2 holes in 1 in software. He is a true rock star of open source. And so if a few of you have heard of Linus, and I'm sure many of you have not heard of me, but my one claim to fame is that I am Linus Torvalds' boss. That's right. Now, I'm also the boss of someone else. This girl right here. That's my 8-year-old daughter, Nisha. I am her boss as well. And weirdly, she actually shares quite a few things in common with Linus Torvalds. They are both adorable. That's right. They're both geniuses. And neither of them listen to anything I say. The important thing I want to talk to you about today is that open is here to stay. No modern technology system in the world today can be created without using open source software. The reason for that is today's systems are so complicated, so much code needs to be written to power these systems that no single company can write all of this software by themselves. There's just too much code to be written. And the market is validating this. Today, there are over 3.8 million open source contributors in the world, 31 billion lines of code committed to open source repositories. Here in Silicon Valley, hundreds of open source technology companies are being invested in. 11 of those are unicorns, valued today at over $1 billion. Billions of venture capital is pouring into open source-based startups, and billions of dollars of public equity is being created through these systems. The easy way to think of how important open source is as we move to this world where there is a tremendous amount of software and technology being created is that almost all major technology companies are moving to a strategic use of open source. Previously, organizations would base about 30% of their code on open source. The rest of it would all be code they'd have to write themselves. Now what's happening is that organizations are taking the vast majority of their code and using open source, code that they jointly create with their competitors and outside of their firms to power all of the products and services they create, and only focusing their internal resources on the things that really add value to their customers or to their constituents. So all of the plumbing, all of the middleware, the infrastructure, the underlying code is open source these days. And then the user interface, maybe in an automobile, it's the instrument panel, the heads-up display, the in-vehicle informatics systems. It's just the user interface. It's connecting the sensors in the car that are unique to that particular vehicle where organizations focus their spend. All the rest of it underneath is open source. So how does this specifically relate to the transportation industry? Well, the reason this is so important is because the transportation industry is becoming a software industry. More and more of the technology that we are going to use to connect vehicles, to do intelligent transportation, is going to be done in software. Literally, the physical nature of software networks, the actual hardware itself, is being abstracted into software through server virtualization, network virtualization. All of these things are being written in software. And you know, I first started talking about this in the transportation sector about 6 years ago in the automobile industry, where I went to the auto sector and said, you know, the automobile industry is becoming a software industry. And you have this tremendous new competitor, this formidable competitor that's competing with you for the in-vehicle experience, the experience of the information systems, the navigation systems, the heads-up display, et cetera. And the auto sector was like, well, who is it? You know? And who might you think that is? Maybe a auto upstart like Tesla, something like that. No. It was a partnership between two things: a piece of Velcro and an iPad. And it looked something like this. You see, what was happening in the auto sector is that navigation, entertainment, all of these things were being sort of usurped, not by another auto company, but by the world's largest company, Apple. So the auto sector in this case wasn't competing with another auto company. It was competing with the most well-funded, one of the most talented software development and technology development companies in the world. And since then, the auto sector has come a long way, and the transportation sector has come a long way in incubating a huge range of companies, of software solutions across almost every aspect of the vehicle. whether it's connected car, whether it's driver safety, whether it's navigation, the in-vehicle experience, maintenance, and so forth. There is an entire ecosystem, a software ecosystem that is growing up, being incubated here in Silicon Valley and places like Michigan and other parts of the world to address now the incredible connected vehicle. And the important thing I want to share with you today is that as the transportation industry in every aspect becomes a software-centric world, you should understand that open source is essential to software as much as software is essential to the future of transportation. The gentleman for Lear this morning pointed that out. And so what I want to talk to you about today is the kind of questions you should be asking yourself, both in the private sector and in the public sector, about how you embrace this change and how you embrace open source. For companies, it's a very simple question. How are you managing external R&D? If 80% of the code in the systems that you're using or creating for any technology, product, or service in the transportation segment, if 80% of that software code comes from outside of your company, how are you managing that? And at the Linux Foundation, we want to help companies all over the world intelligently manage the joint development, the internal consumption, the business process, the legal obligations, all of the things that you need to do to intelligently take software from outside of your firm, bring it into your firm, integrate it into your products, release it back to the open, to be able to jointly maintain a code base so you don't have to. There's a set of steps that every firm should take to intelligently do this. The top technology companies in the world, the top 10 or so, spend roughly $60 billion in R&D. The amount that you can spend to simply harness tens of billions of dollars of external R&D it just is minutia in comparison. So if you're in the technology sector or even the public sector and you're using this technology, somebody in your organization should be in charge of this. And we work with lots of companies in the transportation sector who are doing just that. Let me give you an example. We have a project called Automotive Grade Linux. Toyota, Ford, Jaguar Land Rover, Nissan, Subaru, Mitsubishi, and others, some of the largest automotive OEMs in the world, are partnering with almost 100 of their partners, their tier 1 suppliers, and many more, to create an automotive reference platform. The in-vehicle infotainment experience, a heads-up display, the future software cockpit of the vehicle. This is a freely available, jointly developed, anybody can use it, completely no cost, for anyone who's creating an in-vehicle experience. And that open source project is going to dive down into the subsystems, the telematics, and other components of software components of the vehicle, so that those systems can be maintained jointly over time, those systems that are critical to any vehicle, but not competitive in the sense that it differentiates one vehicle from another. This is the only way Toyota, Ford, all of these OEMs are going to compete with Apple, because those companies are not traditionally software companies. And so in order to accelerate this development, they're jointly doing open source in order to catch up and then subsequently get ahead. And it's not just in automotive. Every single aspect of the connected world, whether it's real-time operating systems like our Zephyr project, whether it's connectivity protocols like our All-Scene project, our IoTivity project. We have an open source UAV project, drone code, that powers the majority of the software inside of any unmanned aerial vehicle. You see most of the cloud, most of the internet, Amazon, Facebook, Google, the vast majority of the software that we use to connect everything on the internet that will subsequently connect everything in the transportation sector is built on these kind of open source projects. The big data platforms like Hadoop and others, all open source. And so companies should manage external R&D, understand these projects, consume them intelligently, manage them efficiently. But for this audience, I think it's important to understand, for policymakers, how are you supporting this kind of shared R&D? This kind of shared R&D that will get products to market faster, that will enable companies to better themselves and better others at the same time. Something that policymakers should be intimately concerned about. And I'd like to make a few suggestions today along those lines. My first suggestion, we need more lawyers. I knew that would get a laugh out of this crowd. We don't literally need more lawyers. We need more lawyers trained in the knowledge of sharing intellectual property. You see, one of the first things that makes it difficult for any organization, whether you're a car company, whether you're someone doing vehicle-to-vehicle work, is your lawyers will say, whoa, if we do open source, if we share our intellectual property, aren't we giving away all the value of our company? Aren't we going to recklessly abandon market incentives? That's not how it works. You see, there's a very simple set of norms of copyright licenses, patent obligations, trademark licenses in order to have standardization. These are the intellectual frameworks that govern sharing of software. If we had more lawyers out there who knew how to keep what they want to keep and share what they want to share, we would get even more code than the tens of billions of lines of software that we're already seeing out there. I spend a disproportionate time in my job not working with developers, but essentially training lawyers that it's okay to share, to keep what they want to keep and share what they want to share. So this is something that I think people in policy positions should consider. I think we need more continuing legal education. I think we need more training. I think we need more online training for this kind of thing. We really do need more open source savvy lawyers. But today I want to talk about an issue that I think is on everyone's mind, particularly after Secretary Miretta's compelling talk. What we also need is a collective response to software security. How many people here have read a headline or seen something in the news in the last month about some kind of cybersecurity breach or some sort of cybersecurity problem, right? We're seeing these on a regular basis. And so to understand cybersecurity problems, I thought I would use an analogy that might be near and dear to all of your hearts in the transportation sector. You know, I grew up in Minneapolis, Minnesota, and this is the I-35 bridge. I used to go over this bridge every single day on my way to school. This, in 2007, was the most traveled bridge in Minnesota. And on August 1st, 2007, the I-35 bridge, and I'm sure most of you remember this, collapsed, killing 13 people and injuring many others. You see, a lot of the infrastructure in the United States transportation system, as all of you are well aware, needs help. Well, it turns out that even though the internet is a lot younger than the transportation system in the United States, the internet is also made up of roads and bridges. And those roads and bridges in the internet are made up of open source software. And about 2 years ago, we had our I-35 moment on the internet. And it was called Heartbleed. How many people here remember the Heartbleed bug, right? Quite a few of you. Heartbleed was a bug in what's called OpenSSL. You know that little lockbox in the upper corner of your web browser? That little lock that tells you you can enter your credit card and no one's going to get that information? That little lockbox that allows you to have private communication? That little lockbox is made up of an open source software project called OpenSSL. OpenSSL had a critical vulnerability that was being exploited for nefarious act. And essentially that lockbox that we all thought was securing our private communication on the internet, turns out was not. In fact, these kind of cyber vulnerabilities are so important to the privacy and integrity of the internet these days, they get their own little logos. The bash bug, right? Shell shock, right? And network time bugs, all of these different things, right? These are open source vulnerabilities that expose the private data and information of the world to everyone else through software mistakes. And this just isn't just an open source problem. There's a whole bunch of proprietary software. The Flash media framework has bugs like zero-day vulnerabilities like this all the time. We see this over and over and over again in software. So security problems aren't an open source problem. Security problems are a software problem because software is complex and difficult to write and prone to error. And actually, in open source, most open source projects, and statistics have proved this time and time again, studies have proved this time and time again, that open source is actually more secure than proprietary software because of something called Linus's law. Linus's law says that given enough eyeballs, all bugs are shallow. You heard the gentleman from Lear mention this morning. The peer review of open source, the fact that everyone can see the source code, everyone can identify vulnerabilities, everyone can then collectively remediate those vulnerabilities, and you cannot sneak a vulnerability by someone very easily because we're all looking at it, should make open source more secure than everything else. And that generally proves to be true. But we have failures. Just like the I-35 bridge, which was in disrepair, just like the potholes you run over on any road, we have potholes on the internet that are creating real security vulnerabilities that are affecting everyone's privacy and security. And let me tell you where those come from real market failures. This is Harlan Sten. He maintains NTPD. He is literally the timekeeper of the internet. NTPD is the code that synchronizes time across all of the major servers on the internet. Literally, the guy who maintains time on the internet, up until we helped him, was basically making about $25,000 a year maintaining that code base out of his house here in San Jose. That OpenSSL Heartbleed bug, those folks were cobbling together that project with about $2,000 a year in donations. Steve Marquez and Steve Henson were working together to maintain this code base. The internet was literally secured by two guys named Steve. Bash, the shell shock bug, guy was working mainly alone. So, as was mentioned in my introduction, we started 2 years ago a private effort to go collectively respond to these challenges. We need to go and fix the potholes of the internet. We raised millions of dollars, and we started creating a program where we could go out and identify those vulnerabilities that will affect all of us. And let me just be clear, you can't just swap out this software. It would take 10 years to go and replace all of these different software components due to the interdependency of the thousands of different software components that rely on these systems. So what we did was to say we need to go fix the potholes on the internet, we need to create a culture of secure coding, and we need to get tools and resources into the hands of developers to securely code that themselves. We created a census project with the Institute for Defense Analysis and our member organizations to go and find the intersection between criticality to the security and integrity of the global internet and screwed up. We looked specifically for those different open source projects that we could go in and apply resources to, audit the code base, provide testing, provide bug and remediation support, add resources to identify these critical projects, work with small teams to remediate these issues. We decided that it was more than just the need to go fix the potholes, that the root of the problem in technology is that you have to think about security when you actually write the code, right? And because open source is collectively developed, I cannot tell a software developer at a company if you don't write your code securely, test it, fuzz it, do static analysis, take a threat modeling class, that I will fire you, right? because that's not how it works. We don't work in a command and control world anymore. And so what we did was we created a badging program that allows the most important open source projects on the internet to self-identify as having met a criteria for secure coding practices, to be able to show that those projects are doing testing, are doing good threat modeling, are doing secure code development. And that would allow these projects to be adopted in a safe and reliable manner by folks in the, let's say, intelligent transportation sector, and everybody else, and would provide them an incentive to get security right by enabling their code to be written securely. And what we decided as well is that we weren't just going to force people to sign up for secure coding practices, that we would actually give them the tools to do secure code development directly. And that involves two big things: education, to be able to teach developers how to think about writing secure code. You know, create educational and tutorial massive open online courses on edX that teach developers how to do things like threat modeling and secure coding. And then provide tools to be able to do static analysis tests, to be able to essentially make sure that software is checked for security problems before it goes out and can create another heartbleed. And so far, the results have been extremely positive. And as was previously mentioned, we are partnering with the Obama administration in what I think is a great example of a public-private partnership to take this program to the next level with more resources, more participation. I just took this a couple days ago from the OpenSSL project. This is a chart of resolved bugs on the top and open bugs on the bottom. And since we've invested, what you can see here is the number of vulnerabilities, essentially bugs, in the OpenSSL project have dramatically been closed out, and there's not a lot of more. The number of bugs coming in has gone significantly down. This was a small investment. Imagine if we applied these practices to every single open source project, for that matter, every single software project, proprietary or open source, in the world. We could do tremendous things. That's why we're partnering with the Obama administration. That's why we'd like to partner with people in the transportation sector. We think this can have a massive impact. Because as I explained, open source projects really are the roads and bridges of the internet. Every major of the top 1,000 sites on the internet, 99% of them are built on open source software. And we can work together to make those roads and bridges great, more secure, pay off the technical debt of 25 years of vulnerabilities that have been introduced through market failures, and really make the future of transportation more secure, and for that matter, the future of all software more secure. Thank you very much.